In the previous lecture, we discussed the quantum theory of light, also known as the photon theory of light, which was introduced by Albert Einstein. It basically states that a beam of light consists of individual discrete particles known as photons that carry a certain quantity of energy. So the experiment that was conducted to validate this theory became known as the Photoelectric Effect experiment, which we'll discuss in this lecture. But first, let's define what the photoelectric effect is. So basically, if you take a beam of light and you shine that beam of light onto the surface of an object, usually a metal, electrons will be emitted from that surface of that metal. And this effect is known as the photoelectric effect. And the photoelectric effect was used to validate the quantum theory of light, the fact that light consists of photons. So let's begin by outlining what the experiment consisted of. So a small metal plate and an electrode were placed inside a vacuum, inside an evacuated glass tube that is known as the photocell. So the photocell is shown in the following region of this diagram. So this is our electrode, this is our metal plate, and this is our evacuated glass tube. Now, the plate and the electrode are connected to a battery as shown and to an ammeter. And if there's a voltage inside that circuit, then this ammeter is able to pick up that voltage. So the ammeter is a device that reads whether or not there's a voltage inside that circuit. Now, in the absence of light, if you take this setup and you place it into a dark room, no electrons flow inside that circuit because we essentially have an open circuit. And that basically means the ammeter reads a voltage of 0. However, if you shine a beam of light onto this metal tube or this metal plate through the glass tube, then electrons are emitted from the metal plate and they travel across to the electrode because the electrode has a positive charge as a result of this battery, and the ammeter picks up a voltage. So before we state what the results of this experiment showed, let's discuss the wave theory of light. Now, if light does in fact behave as a wave and not as a particle, then the following two things must be satisfied. So, if monochromatic light that hits the plate does in fact behave as a wave and not as a particle, then the wave theory of light predicts the following two things. If the intensity of the light is increased, then the number of electrons emitted from the metal plate and the electron's maximum kinetic energy must increase. And two, the frequency of light should have no effect on the kinetic energy of the electrons. Only the intensity actually should affect the kinetic energy, the velocity of our electrons. So these two things are predicted by the wave theory of light. Now, on the other hand, what exactly should the quantum or the photon theory of light predict? So in quantum theory, a beam of light with a frequency given by F consists of individual photons that each carry the same exact quantity of energy given by H multiplied by F, where H is Planck's constant and F is the frequency of that particular beam of light. Now, the quantum theory of light tells us that by increasing the intensity of the beam of light, you increase the number of photons that beam carries. For example, you increase from 10 photons to 20 photons. That's what we mean by increasing the intensity under the quantum theory of light. However, by increasing the intensity, we are not actually increasing the energy of each photon, the energy that each photon carries, in contrast to the wave theory of light that states if you increase the intensity, you increase the energy. So, according to the quantum theory that was proposed by Albert Einstein, a single photon essentially collides with a single electron. So it's a one-to-one collision in the metal plate. So, in order to emit an electron, the attractive electric forces between the electrons and the protons found in the atom of the metal must be overcome. That is, the single photon must do a certain quantity of minimum work given by W naught to actually release that electron. And this work is known as the work function of that electron. Now, if the energy that is carried by the photon is less than the work function of that electron will not be emitted. So, we have the following two important results. If H multiplied by F, which is the energy that is carried by a single electron, is less than the work function of the electron. In other words, this gives us the quantity of energy that must be gained by the electron for it to emit itself. If this is true, then electrons are not actually emitted because the photon does not have enough energy to give to that electron to emit it. However, if the amount of energy carried by the photon is greater than the work function of the electron, then electrons are in fact emitted and the remaining energy goes into the kinetic energy of the electron. So the electron is emitted with a certain velocity, and we get the following important equation. So H multiplied by F, the quantity of energy carried by that photon, is equal to the maximum kinetic energy of the electron plus the work function of that electron. If we rearrange this equation, we get that the maximum kinetic energy of that electron is equal to the difference between the energy of the photon and the work function of the electron. So we can only use this equation as long as we're assuming that the amount of energy carried within that photon is greater than the work function of that electron. So this is what is predicted using quantum theory of light as was proposed by Albert Einstein. Now, what exactly were the experimental results? So result number one. If the frequency of light is less than the frequency required to emit electrons from the metal, then increasing the intensity will have no effect on emitting electrons. In fact, if the frequency is less than the required frequency to emit electrons, electrons will not be emitted at all, no matter how intense the light is. And that basically contradicts point 1 and point 2 of the wave theory of light, and it essentially states that the quantum theory is in fact true. And the second thing that was shown by the experiment was as follows. If the frequency is large enough so that our electrons are emitted from the metal plate, increasing the intensity does increase the number of electrons emitted, but the maximum kinetic energy of the electron is not changed. What will change the maximum kinetic energy of the electron is if we increase the frequency of that light. If we increase the frequency of light, we increase the energy that is carried by that photon, and so the maximum kinetic energy of the photon will be greater